All right, good morning, good afternoon, actually, guys. Let's do a quick audio and visual check. If you can hear me and see me, give me a thumbs up in the chat. If you can hear me and see me, give me a thumbs up in the chat. All right, cool. Let's see who we got today. All right, we got Elena. What's up, Elena? Good to have you back. Bernice, good to see you. Lucy, good to see you. Dom, good. Maddie, good. Elizabeth, glad for you to join us back instead of skipping out on lecture. Good afternoon, Miss Gibson. Maddie said, yes, Maddie, I got your email. Good morning, Kristen. What's up, Abby? Kelsey, Abby, Bernice, Maddie, Caitlin, Elizabeth, Kelsey, Kristen, Abby. Abby, get better internet. That's the only thing I can say. Already, boom, roasted. Already starting off with jokes. So, I can't help if it's blurry. Okay, good. It's good now. All right, very good. So, good. I don't even know what day it is. Wednesday afternoon to all you wonderful people in honors algebra. How I miss you guys so much. You'll probably continue to hear me say that throughout these next couple weeks. I'm kind of tired of this, and I'm sure you guys are as well. So just want to let you guys know I miss you, and wanted you to know that I hope you all had a wonderful spring break. I don't know if anybody went anywhere crazy or did anything. I know. I'm sorry. I do apologize, Abby. I shouldn't roast you right off the bat. So I don't know if anybody did anything crazy over spring break. We went to our backyard. Pretty fun. Good sights. Good sounds. Not too bad most of the day. So overall, pretty good. Pretty good spring break. Very restful and very very nice time off. A lot of people think like teachers aren't doing anything right now. So it's like I get texts from all the time. It's like, man, it must be nice to be a teacher. It's just like actually it's harder. So, but last week was a joy. Hope you guys had a good spring break. I really don't care if you had a good spring break or not. I'm just joking. But I normally would say that after a break that I really don't care if you had a good Christmas or whatever break it may be. But I do hope you had a good spring break though. Okay, good spring break within all that. All right. Let's talk about a few things, turning stuff in. Okay, as I told you before the very beginning of this, I said, hey, you're gonna turn stuff in, and I said April 14th, but I knew I'd give you a little bit of leeway, and if I don't, they'll scream at me that I'm not giving you guys grace, and that's not of Jesus Christ. So I must extend grace to you. I must give you what you don't deserve. If you remember the difference between mercy and grace, I must give you what you don't deserve by allowing you to turn this in all week. All right. So, turning stuff in, I sent you the email. Just want to review that real quick. Option 1, you can take it to the school. As you see this picture behind me right here, you can put your old packet. Right here, you can pick up your new packet. Make sure it's the honors algebra that you're picking up and not the regular algebra. But you can drop stuff off here. Excuse me. You can drop stuff off here. It's basically going to be there Friday from 8 to 4, or basically tomorrow and Friday from 8 to 4. I am picking up whatever there is from 8 to 4. I did see yesterday, I went by there, and I did see where you guys had turned some stuff in. I have received, I think only Maddie from this class. There may be another one, I'm not sure, that has sent it to me PDF. Again, totally up to you either way. I don't even have a printer in my house right now. So I know it's kind of hard for some of you to get the paper, so that's why I wanted to make that an option of you getting the new packet with everything. Just drop your old packet here. I will grade these on Friday, okay? So I'm going to go to the school at 4 o'clock. Anybody that sent me any emails, I'm going to pick up those. I'm going to put those in the grade book. So then your grade book should reflect everything from Chapter 4, all your homework, your study guide, and your test, which you guys already took. Seemed you guys did a pretty good job of cheating. You all did fairly well. So your cheating game is on point. So keep that up as well. Continuing right along on our agenda for today. So we want to get a more consistent routine going. Just so basically for the next 3 weeks, we will do every Monday and Wednesday. Okay. Here, maybe I can. Oh, now I know how to do this. Yeah, there we go. Almost like I'm in my own thing now. All right. So every Monday and Wednesday at 2:30, we will meet. Okay. So I will get with you on. Basically, you saw that schedule that I had sent out to you. I sent you the email, then I sent you a calendar. I hope that helps. So every Monday and Wednesday, and then as you see at the very end, I think it's April 30th, we will have a Chapter 6 test that day. All right, so Mondays and Wednesdays at 2:30, just mark that in like, hey, this is going to be when we're going to have it. I hope that time works well with you guys, and that'll just be every Monday and Wednesday. I'm not going to have any class on Friday for you guys, okay? So make sure you are staying up to speed, okay? This is so valuable that you stay up to speed, guys. Please, please, please stay up to speed with stuff because a lot of you are scrambling around right now, texting each other saying, hey, can you send me your 5.4 homework? So I can copy it down so I can turn it in, okay? If you stay up to speed, your learning will be so much better, and it will be a much, much, much better learning experience for you if you stay up. Do the notes, do the homework, okay? So that is that. And then the next thing was if we want to do Zooms on Fridays, okay? So not this Friday because I had to do a small group chapel. So not this Friday, but maybe next Friday. I'll put it on the calendar. Maybe we can meet at 2:30 on next Friday and just maybe talk about some, just talk about anything you guys want. That way we can see everyone. I know you see each other, and I think chemistry, maybe some, psych, maybe some other classes like that. Not 100% sure. But what are your thoughts on Zooms on Friday? Well, not mandatory or anything, but is there interest in that we do that? We can do a Q&A. We can do whatever then, so we can all see each other. Does that sound good? Oh, Elizabeth, you want to do the Zoom meeting. Well, maybe, Elizabeth, you should join live lecture, and then we'd be really intrigued to let you join the Zoom meeting. But it's good to see you here for the first time since the first time. Have you attended any of the live lectures, Elizabeth? Yeah. Okay, sounds good. We can do that. And I got to call Sebastian out because Sebastian's not in here. Now watch this. He's about to snipe in the chat box. Like, I'm here. You have not attended a good amount of lives. You have not. You have not. All right, so maybe Sebastian is not here. Oh yeah, Josiah's gone. Josiah's gone too. As long as his grades are good, that's all that matters. But someone may want to remind Josiah that his fourth quarter grades does impact whether he plays in the fall or not. That's crazy. If it would have been that way when I was in high school, I would have done better in high school. But it was not that way. It was just, whatever you had in the fall, like what you got on your, your weekly. Well, they send out weekly report cards. I assume they do that here too, though. But man, I would have been on my game during the spring semester if they would have had something like that when I was there. Okay. Yeah, okay, maybe 2, Elizabeth. All right, so next thing we want to talk about is files, okay? Guys, anytime you need anything in here, it's going to be under your Canvas, under the files, okay? So if you all go to your class, Honors Algebra, and you look on this page right here where it says Files, you can access this from your phone. I've put them in chapters. Now, notice in Chapter 5, I'm going to be a little bit more consistent about scanning stuff in, but like 5.3 notes completed. So all the notes and homework is on there right here, but also I'm going to attach whatever we do in class as well, whatever we do online, so you'll have access to that, okay? So for this, if you did not pick up the Chapter 6 packet, the new packet, oh man, you guys are getting into it. Yeah, oh yeah, Elena skipped too, Elena. Don't act like Elena, don't even act like I didn't even see you skipping. Don't worry, I got that letter of recommendation to write that you're very not in class. I guess maybe I don't know. I'll try to work on that. Let's see what your attendance is like now. All right, but these are all of our files. If you did not get a new packet, this is right here is where you'd print them off at. These are blank copies here. So after this class, I'm going to scan in like 6.1 notes completed. So, all right. And yes, I did see many of your homework's already turned into the box, so I do appreciate that very much. Last thing, email me with any questions. I think you guys know this pretty well, but there's no student who should be saying, I don't have a clue what to do in Mr. Oppach's class. I think that it's all pretty good in terms of you all knowing what you're doing. Okay? Getting into a little bit more consistency with exact days and stuff. I didn't want to push you guys too much, but I want to get done with Chapter 6 so that in May we can spend a little bit of time with trigonometry. Again, I was hoping to start trigonometry once we got back from spring break in school, but obviously with all of this, it's slowed us down a little bit. But have no worries. You guys should be okay in terms of being prepared for pre-calculus. I can tell you this, that it is looking like if everything goes smooth, I should be teaching pre-calculus next year. So you guys should be okay when it comes to trigonometry, this portion, because once you get into pre-calculus, that'll be one of the first things we begin to cover in that class. So again, that's if everything goes smooth. There's a lot of boxes and hoops to jump through and stuff like that. So, but I can. Some of you've been asking me, hey, do you know what you're doing? Do you know what you're teaching? And I can tell you that if everything goes smooth, I should be teaching pre-cal, of course, Algebra 2 and AP Calc. So, just kind of letting you all know within that. With that being said, again, email me any questions you guys may have. I'm here for you if you need me. But with that being said, let's jump into this. Let's go ahead and jump into this lecture, lecture 6.1 notes. So I'll minimize myself here so we can maximize our notes. Go ahead and get these notes out. If you got these notes out and you're good and you're ready to go, give me a thumbs up. All right, I think I'm seeing everybody in the house. Cool beans. All right, so guys, going to Chapter 6, okay? Now, Chapter 6 is all about exponential and log functions. Chapter 6, oop, that pen ain't gonna work. Chapter 6 is all about exponential and logarithmic functions. Okay, so that's what Chapter 6 over, and then Chapter 6 is over the key features of the graph, of the functions. So key feature 6.1 is over key features of exponential functions. Okay, key features of exponential functions. All right, so Guys, we've done a lot of, again, Algebra 2 is a lot about functions. So we started with our basic parabola, x squared. Then we went to x cubed, the snake. We also know about the absolute value of x. And then we went to from there, I mean, I know we went to 1 over x. 1 over x. And then now we are going to exponential. Can't think of any more. I feel like there's another one. What's another one that we did? I can't remember. Rational. Oh, yeah, cubing. Sorry. The one that we just got off of. So the square root of x looks like that. The cube root of x looking like that. And then, so now we're going to exponential functions. So we've done 1, 2, 3, 4, 5, 6 basic functions. So now we will move on to exponential functions. Okay? Now we'll move on to exponential functions. So an exponential function is any function in the form of y or f of x is equal to a times b raised to the x power. Okay? Where a and b are constants with a not equaling 0, a cannot equal 0 because then it would be nothing. B has to be greater than 0 and b cannot be 1. Okay? Now, next week when we get to lesson 6.2 notes, you're going to see like more of a real-world application with the whole exponential functions. One of the biggest things that, one of the biggest areas where exponential functions exist is really in the stock market and accounts. I'm going to say stock market and retirement accounts. Those are like 401ks, Roth IRAs, stuff like that. Okay? Now, let me just talk to you a little bit about some of that. So, I want to take you real quick. This, to me, helps you see that more of that exponential thing than anything. I have it on my computer. Let me pull it up on my iPad. Okay. Okay, so here is a chart, okay? And what this chart consists of, okay, is people these two guys. We got Ben on the left side and we have Arthur on the right side, okay? And this is a perfect representation of an exponential function in the real world, okay? So Ben is 19 years old, all right? He invests $2,000 a year, okay? And $2,000 a year is not a lot. $2,000 a year would be about $166 a month, okay? So he puts $166 a month into a Roth or into what we would call a mutual fund. Okay, now a mutual fund is kind of like it's basically where a company takes. Okay, so yeah, and I might have. I don't know if I showed you this or someone else. I don't know if someone else has showed you this or I've showed you this. This is something that Dave Ramsey shows a lot. So if you've seen this, just kind of go along with it. If you haven't, it's kind of a cool thing. So what a mutual fund is, going back to what a mutual fund, it's basically a mutual fund is a fund that you put money into, and a company takes that money that you put in and invests it into the stock market. Now what the stock market is this, okay? The stock market is an open forum for people to put money into companies, okay? So if I put $100 into Apple, okay, then I'm going, whatever they grow as a company, as their chart goes up, I could make a bunch of money off of that. Dave Ramsey, one of the financial gurus in our time, says that the stock market grows at 12%. Now this right here is growing at 12%, okay? This interest right here grows at 12%. So basically whatever money you put in, you're going to get 12% of it back. So if I put $100 in, I'd get $112 back. That would be 12%, okay? So a mutual fund is just an account that you put money into, and a company then takes that money and invests it in the stock market for you. Now, right now, something very terrible is happening with our economy. It's gone down. So when that happened, when businesses shut down, the stock market started running down. It hasn't crashed or anything yet like it did in 1930 or 1929 during the Great Depression, but it's going down, which is not a good thing. So that is where the big debate is right now with President Trump, with the committees, with the Democrats, with the Republicans, is, hey, I understand that people are dying and sick, but our economy is dying and sick, and that's going to cause more hurt. So there's a big debate about, hey, what do we do here? Do we do we open businesses back up, or do we risk? And like, there's a big debate right now, and maybe that's a Zoom question for next Friday. Is, hey, what are your thoughts on that? Okay, don't answer those now though. So be thinking about that. What are your thoughts? Should we open our economy back up to see the stock market and our economy turn around, or should we stay safe and be a little bit clear and stay in quarantine, or should we have a hybrid model? Should there be some kind of like, hey, where there's a mix or something? So, and of course, within the next 2 weeks, we may hear a lot in the news and stuff within that. But the stock markets stocks go up and down, okay? But mainly they travel at about 12%. Now, I'm going to pull up a stock. Can someone like type in the chat box, what stock do you think's up right now? What stock do you think is up right now? What stock do you think is up right now? Anybody? Yeah, hand sanitizers, Amazon, Zoom, yeah. A lot, yeah, online shopping, okay? So here is Google, okay? Here's Google stock. Now again, right here when some of us was at junior retreat, all this happening, so this is where it was. This is where we say our economy was booming, okay? This is where Trump brags about, hey, how awesome our economy is doing, and it was reaching records high, okay? So looking at this right here, you can see this plummet. That was the coronavirus effect, but now you start seeing it come back up. But yeah, I did see some interesting things from you guys. Somebody said Zoom. So if we look up Zoom right now, Zoom, yeah. So this is a great example right here, okay? So Zoom if you would have bought stocks in Zoom, and I really can't, I wish I could zoom in here, but if you would have bought stocks in December of last year in Zoom, you would have paid you would have paid pennies for the stock. But now look at where it is now due to this. Even in, you can see a little bit of dip in March, just when everything kind of fell apart, but then you see it rise back up. So over here, you would have probably paid about $40 a stock. Now your stocks are around 162. So that's 4 times your money. So if you would have invested, $4,000 in Zoom in December, then you would be sitting at about $16,000 right now in profit. So that is just kind of an example. And notice here what I want you to notice. You see this kind of general curve right here. You see that curve? And that's really what we're going to be talking about today with exponential graphs, exponential equations. Okay? And of course, there's probably some other ones that you could see. Right? Yeah, get it. Wish I could zoom in there. So, and you will see, like, it's just crazy. But who could have in December predicted a pandemic that would cause a video conferencing company to just boom through the roof? I mean, it's practically impossible to even think of something like that. But to finish off, sorry, I should have done this. But to finish off this chart right here, and I've shared this with you before. Sorry, I don't know who I've shared it with. I assume the whole class, but I'm not sure. This guy from 19 to the age of 26. No, don't worry about Josiah. But from 19 to 26, he invested $2,000. That's 1, 2, 3, 4, 5, 6, 7, 8. $16,000 is what he invested from 19 to 26. And that would have already grown to $27,000 when he stopped investing. And we can see down at the bottom, he never invested again. But Arthur over here, who invested, who didn't start investing until 27, but put in $2,000 every single year, he's putting in quadruple what our guy Ben is. And you see at the end of their retirement at 65, my guy Arthur, who only put $16,000 in, because he did it so early, his investment turned around because his money grew exponentially. Same thing here with Arthur. His money still grew. Okay, this is a huge amount compared to what he put in, but still, the early investment is what's very, very powerful for those numbers to grow exponentially. Okay, so here we go. It says sketch the graph of each function, identify the domain, range, intercepts, asymptotes, and end behavior. Okay? So, let's get started with this. Number 1. Looking at number 1, if we're dealing with f of x is equal to 2 raised to the x power. Now, just like we've done with every single one of these, we're going to create an xy chart. So, 2 raised to the x power. So, if I make an xy chart here, let's start with something like x being 3. So that is 2 cubed. Okay? 2 cubed, and 2 times 2 times 2 is 8. Okay? So when x is 3, the y is 8. Let's go ahead and do 4, 2. This graph is fairly large, so let's go ahead and do 4, 2. 2 times 2 times 2 times 2 would be 16. So when it's 4, it's 16. And that's about as high as we can go there. So then let's go to 2. If we plug a 2 in here, 2 squared is 4. If we plug a 1 in here, that should be 2. So let me 2, 4, 1, 2. If we plug a 0 in here, that will take us to 1 because anything to the 0 power is 1. So 0, 1. Then let's put in negative 1. Now that would look like this. 2 to the negative 1 power. What do I do with that negative? Let's see if you can remember from lesson 5.1. What do I do with that negative there? Christina said put it in the denominator. Remember, we kick it out, right? Kick it out. Whatever I have left, put it over 1. Yeah, so kick the negative out. Whatever I have left, put it over 1. So 1 over 2 to the first power, which is just simply 1 over 2. Very good, Lucy. So that would be 1/2 there. So negative 1 and 1/2. How about negative 2? Negative 2 would be 1/4, right? Negative 3 would be 1/9. So, what is that creating for the x-axis? What is that going to tell me about the x-axis? Someone type that in the chat box. What is the x-axis going to be? Anybody remember what the x-axis will be? Yeah, it should be at 9. No, it should be at 8. Sorry. No, because, sorry, Abby, 2 cubed, 2 times 2 times 2 is 8. Yeah, very good, Kelsey. It will never touch the x-axis. So what is it called when something, it's approaching a line but it never touches the line? What is that line called that it never touches? The asymptote. So our horizontal asymptote here, it asks for asymptotes. Our horizontal asymptote will simply be y equals 0. It will never touch that right there. Yeah, very good, Lucy. You're cool. It's math. We don't care about spelling. Okay. Not always be y equals 0, Abby, but because it can change depending on if the graph goes below it, but it will always approach a horizontal asymptote. Okay? So then from there, we're going to simply graph it. It's going to go like this, and then it's just going to spring upward. Okay. So that's my graph. I've graphed it. I've named my asymptote. My intercept, I got a y-intercept at 0, 1. Got that. And then I need the domain and range. I didn't really leave a lot of room here. I apologize. Domain and range. Kelsey, will you give me the domain of this graph? And Elena, will you give me the range of this graph? Yeah, cool. That's what I thought you meant, Kelsey. Good. From negative infinity to infinity. And then, Elena, do you have the range? Elena probably bailed out again. Yeah, very good. 0 to infinity. And the y will never be 0. It will never reach it. So that's my domain and my range there. And then Maddie asked for the second time, what about vertical asymptote? So does this have a vertical asymptote anywhere on it? Do you see anywhere that the line approaches but doesn't hit it? If there's not, then there's not a vertical asymptote. No, I actually, no, Maddie, I saw yours, that question about the one. I saw that. I just didn't mention it till then. Okay, so there's no vertical asymptote, so we don't have to worry about doing anything. There's no vertical asymptote, so I've taken care of the intercepts, asymptote. I've taken care of range and domain. Now I just got to identify the end behavior. Now, if you remember with end behavior, I had you... Oh, really? With Elena? Oh, yeah. Maybe, I don't know. Could be Elena, not me. All right, so continuing on, though. So if you remember with end behavior, I had you write it like this. The f of x as x approaches infinity for 2x is equal to this, okay? And that's what the end behavior of this should look like, okay? So I'm going to write that here, just kind of showing you an example up there. So the f of x as x approaches infinity of the function 2x is equal to. So again, remember what end behavior is. What is the y doing of the function as x approaches infinity? What is y doing as x approaches infinity? As x is going to infinity, which would be this way, the y is approaching infinity. Okay? And then likewise, negative infinity, as x is approaching negative infinity of the function 2x. So what is it approaching as it's approaching that? It would be approaching 0. Now, what's the, Christina, what's the y approaching? Now, the x is going towards infinity, but the y would constantly be approaching 0. Okay? All right, let's look at number 2. All right, so number 2, same thing here. Let's make an XY table. Let's make an XY table here for this. Oh, okay, yeah, cool. So number 2, looking at the XY table, 3 raised to the X power, okay? So if I make that 3 to the 3rd power, that's 27, and that'd be off the graph. So let's go with 2. And when X is 2, Y is 9. So when X is 2, Y is 9. When X is 1, Y is 3. When X is 0, Y is 1. When X is negative 1, that would be 1/3. And then from there, we can kind of get our graph. So it should be going something like this. And again, this is just a sketch. It's not exact. And should be going up pretty fast from there. So pretty simple concepts. And these graphs come when you have an exponent in the, or you have an x in the exponent. Okay. If we were to look at it on our graph, y equals, and we were to say 3 raised to the x power, we get the graph of what we have here. And it shoots up. Okay? See a better version of it, we can take the y min out. Oh, took the wrong one out. Sorry. I meant not the y max, the y min. I said it right, did it wrong. And we could make that go to 50 by 2's. And we could kind of see the graph there. Okay? So looking something like this. All right? And this is, again, what we would consider the exponential function. Okay? All right. Now let's do all of the fun stuff. Let's identify the domain. So our domain, the domain of all these should be all real numbers. It will include all real numbers. The range should be from 0 to infinity, but not including 0. Good question, Maddie. Will the y-intercept always be 0, 1? If it's in this form where it's just b raised to the x power, it will be, yes. But not always with not all exponential functions. And you'll see some here in a second. Okay? Then looking at domain range, the y-intercept is 0, 1. Okay, yeah. So the bracket means that it's included in there. But this graph will never hit 0. It will never hit 0. It'll go on forever. No, you're thinking the opposite way, Elizabeth and Abby. A bracket would mean that it includes it. That means it's included in it. A parenthesis means that it's not a part of it. Oh, that's just like in XY form. So if I was to ask you what's the y-intercept of this, you would say it's 0, 1. Okay. Then we look at asymptotes. We know the x-axis is our asymptote, so y equals 0. And then we just need to do end behavior. So what the value of the function as x approaches infinity for 3x is equal to infinity. And the function as x approaches negative infinity of 3x would be 0. So that's basically it right there. Just the graph and then just meeting all these characteristics of the graph. Just like we did with every other function. We've done this with all other functions, like knowing what it was. So that's where we always start within that. Okay, give me thumbs up on that if you're feeling good about that. You're good with that. Give me thumbs up. Yeah, negative infinity. Sorry, yeah. Thank you. Okay. So, looking back, jumping down here to number 3. Now, notice here with number 3, okay? Notice with number 3 that it's not just 2x, okay? And we have something out here being multiplied by the function, all right? So it's not just it's a fraction now. It's less than 1, all right, to the x power. So again, let's make an xy table. Okay. Now, one of the best things you could probably do here is find your y-intercept, and that's the reason why it's one of the things you list. And that's your y-intercept is always going to be when x is 0, what is y? Okay. So when x is 0 here, what is anything to the 0 power? 1. Okay. Anything to the 0 power is 1. So that would be 1 times 5, which would be 5. Again, if I plug 0 into that, anything to the 0 power is 1. 1 times 5 is 5. So that tells me that I know my y-intercept is going to be 0, 5. Okay. Now, what about when x is 1? When x is 1, that would say 1/2 to the first power, which is just simply 1/2. Anything to the first power is itself. And then what's half of 5? 2.5. 1 and 2.5. Notice here we have a little bit of a change of direction. Okay. What about if we put in a 2? I'm going to work this one out. It may not be as simple as the other one. So just say 5 times 1/2 squared. So again, just putting the 2 into the x. So that's 5 times 1/2 times 1/2. 1/2 times 1/2 would be 1/4. And 5 times 1/4, think about if we put that over 1. 5 times 1 is 5. 1 times 4 is 4. And there we have that. And that's actually 1.25. So when x is 2, that is just above 1. 1.25. All right, think about 3. If I put another one, think about the 3 would just be taking another half there, so it'd be 1/4 times 1/2 times 1/2, which is a 4th, times another half, which would be an 1/8. So 5 over 1 times 1/8. It would be 1/8 if it was a 3 here, right? Not 1/3. Excuse me, 1/8. And again, that you may be saying, where'd you get that from? If I made that a 3 right there, I'd have 3 1/2s, and 3 1/2s would make 1/8. And then that's 5/8, which is a little bit bigger than a half. So when x is 3, it's 1/2. A little bit more than a half. Looking something like that. And we know that that's just going to continue down in that pattern right there. Okay? Now let's flip to the other side. And let's go to like -1. See what -1 would get us. All right? Now, I'm going to use a different sheet of paper because I don't want to run out of total room here. So looking at what happens when I put a negative 1 in there? That would look like this. 5 times 1/2 to the negative 1. Now, we went over this last chapter, right? Again, first step, bring that 5 down. The negatives out, and whatever you have left, put it under 1. 1 over 1/2. Now, before you deal with this 5, I would deal with this. This is like this, 1 divided by 1 over 2. So this is where you want to do your keep, flip, change. So 1 over 1 times 2 over 1 would be 2. So again, kick your negative out. Whatever you have left, which is 1/2 to the first power, put it under 1. Now took this right here, brought it to the side. 1 over 1 divided by 1/2. Bring it down, change the sign, flip it, and you get 2. So really it's like 5 times 2, which is 10. So when x is negative 1, your y is 10. So negative 1, 10. What if it was negative 2? So negative 2, 5 times 1/2 to the negative 2. Again, that would be bring your 5 down. Kick your negative out. Whatever you have left, put it under 1. 1 over 1/2. What would that be? 1/2 squared. Now take care of that 1/2 squared. 1/2 squared would be, that'd be 5 times 1 over, that'd be 1/4. Because 1/2 times 1/2 is 1/4. And then take that over to the side, say 1 over 1 divided by 1 over 4. Keep it, change it, flip it. And that would be 4. So 5 times 4 is equal to 20. So when x is negative 2, this is 20. So when x is negative 2, it is 20 way up here. So coming back here, I know it's going to kind of go on this line right here. It's going to go up, 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 up. Looking something like that. So notice my domain. Domain is still negative infinity to infinity. Range is, now this changes because we read graphs from left to right, guys. Don't forget that. My range would be from, or actually the range, I guess it technically wouldn't change because we go up and down with range. Sorry about that. So 0 to infinity is still fine with a parenthesis on 0 because it's not included. And then we had Y-intercept. Y-intercept would be 0, 5. Horizontal asymptote is still the x-axis. And then the only thing we got to do from there is our end behavior. So f of x as x approaches infinity for the function 5 times 1/2 x is equal to 0, because as this function's going towards infinity on the x-axis, the graph is approaching 0. And the function as x approaches negative infinity as 5 times 1/2 x is equal to infinity. Elena, you're on thin ice with me. You better watch it. Oh, I'm sorry. My wife thought I was talking to her. Talking to the other Elena. All right, give me a thumbs up if you guys feel pretty good about that. Give me a thumbs up if you guys feel pretty good about that. Good, Kelsey. Good, Bernice. Good, Elizabeth, Lucy. No, the horizontal asymptote will not always be 0. We'll get to that here in a second. What's up, Jacob Payne? I'm doing good, man. No bother at all, man. No bother at all. Good to see you, man. Hope you're doing extremely well. I don't know, Caitlin. You'd have to ask your mom. All right. So jumping in here to number 4. Jumping in here to number 4. F of x is equal to 2 times 1/3 raised to the x power. Would have been algebra with Jacob Payne. Would have been algebra 1 with Jacob Payne. I'm pretty sure. Taking me back a little bit. I don't know if he's still on her. Jacob, are you a junior or a senior this year? James Madison is the name of the middle school. He gone. Elena trying to holler at my boy Jacob. All right. Shall we continue so we can get done with this? Looking at this right here, let's make an XY table for this. So here we go. XY. It's funny, I actually had another student in another class interrupt saying hey as well. So let's make an XY table for this right here. So let's start, I'd always start with 0. So if you got a 0. All right, Jacob. I wouldn't blow smoke on my feed, man. I'll kick you out of here. You try and blow some smoke, try and say some checkers. I don't even play no checkers. I'd be playing some chess, maybe. I don't remember checkers, man. Your memory's better than mine if it's checkers. I remember playing a ton of chess, but not too much checkers. All right, but Preston Pendergraph got on here too, Jacob Payne. I don't know if you yeah, there you go, chess. My bad. Okay, yeah, cool. You insulted me, man. Try to say I play checkers. I ain't no checkers player. Don't take me to be no little boat kind of guy. I'm a yacht. I ain't no little fishing boat. I'm a straight up yacht. All right, but as we'll try to continue moving forward, but good talking to you, Jacob. I really do hope all is well. Hate it, man, that you guys weren't able to play the state games, man. I'm hoping they still work that out so they can still play them, man. I'm looking forward to seeing those guys play basketball. So, can somebody catch Maddie up? Yes, Maddie, that's correct. So, looking at number 4, XY here 0. When x is 0, y would be 2. So we got 0, 2. Yeah, I know. I hate that, man. Then if we type in a 1, 1/3 of 2 would just simply be 2/3. Hey, you too, Jay. Good talking to you, man. Stay up. So that would be 2/3. So when it's 1, it is 2/3. When it is 2, that would be 2/9. And again, I'm doing a little bit of math in my head here for that. So when it's 2, it's 2/9, which is pretty small here. Then let's go the other way. Let's go -1. If it is -1, should be 6. If it's -2, it should be 18. So you can see how quickly these exponentially, and that's the thing, you'll hear people say, oh, that grew exponentially. That means it's growing rapidly. Okay? And we talked about the chart maybe when we did that trash problem, if you would rather get paid per day or paid by the day or paid by each trash can. You're paid doubles each day or by each trash bag you pick up. I guess that's when we're talking about exponential. Oh, cool. That's what I probably figured. All right, let's go to the backside. Just 2 more problems, guys, and then we're done. I know I've talked a lot today. So this just increases it just a little bit, okay? So looking at this right here, okay? Let's do this first one, okay? Now you're going to see, so this is just kind of adding some changes to it. Oh yeah, I forgot. I'm sorry. We got to answer all those questions. Sorry. So domain, go in here, domain. Thanks, Elizabeth. Hey, good to see you today, Elizabeth. Domain would be -infinity to infinity. Our range is from 0 to infinity. 0 not included, so parenthesis, not a bracket. Then we got Y-intercept is 0, 2. And horizontal asymptote would still be the x-axis. Or y equals 0. And then as f of x approaches infinity, the function 2 times 1/3 x would be approaching 0. And as the function approaches -infinity, 2 times 1/3 x would be equal to infinity. All right, any questions on that? If not, give me a thumbs up. Okay. All right, going to the back side. Okay. Now notice here with the back side. Okay. I actually just want to look at these. I just want to look at these graphs on our calculator. Okay. So, and then we'll just do a rough sketch. We don't have to answer all the questions of it. I just want to show you how this can change. Okay. how they can change that the horizontal asymptote is not always going to be 0 or y equals 0. So let's type this one in. If you have your calculator, you can do this with me. If not, just kind of watch along. 3 times 2 raised to the x plus 2 minus 2. Let me give my window just a little bit of slack here. So let's go window. So as you see here, let me go a little bit more than that. So as we can see here, this one is actually below the x-axis, all right? Yeah, that is. So, here's what I want you to notice about this one. If we really look at everything here, guys, here's what I want to show you, is this. Watch if I just graph the graph 3 times 2 raised to the x power. So not the plus 2 and not the minus 2. Let's see the difference in those two. Okay. So they're very, very similar, these two graphs are. But I want you, here's the point I want to bring up to you here, is that this right here, this would be a vertical translation. Okay. That would be a vertical translation. And this right here would be our horizontal translation. Okay. So, and Maddie's, okay, I think you see it now, Maddie. Okay, so if we notice here, I'm a little blurry. I don't know why. Okay, so if we notice here with this graph, okay, I'm going to take myself out of it just so it's not hurting it even more. Let me turn down the brightness a little bit. Okay, so the blue one, okay, the blue line is this right here. Yeah, Lenny Grace, they hear you whispering. What? So, the blue one is our actual line we have here. But here is our, what we'd call the original. But this one has been transformed, okay? Now notice here, from right here, the outside represents a vertical translation. Remember, anything on the outside is vertical translation. And with it being minus 2, that pushes that down 2, okay? Now, my figures here aren't, I think I'm going up by 3s here, so it could look a little bit confusing. And on the inside up here, the inside with x, that's a plus 2, so that goes left 2. So really what's happening here, this is going down 2 and left 2. And that's what's happening with that blue line. So the main thing I want to show you out of this is that on the outside is a vertical translation, horizontal translation, and how quick it's increasing. Okay, how much it's being multiplied by, so how fast it's increasing on top of that. So we can just draw a rough sketch of this. The Y-intercept on this one is appears to be 10. So, and the X-intercept appears to be, let me see what that is, somewhere around there. Just as long as we have kind of a rough sketch of this going up, okay? And of course here, now the interesting thing here is that because this is shifted down to, at -2, there is a horizontal, that would be a horizontal asymptote. So whatever your number is out here to the side, think on the front side, there is no number, so your number would be 0. So therefore, that's our horizontal asymptote. But whatever number is out here to the side is going to be your horizontal asymptote. Okay, and that, again, I'm not worried about the other numbers for that one. But looking at 6, so the -1 shifts the graph down 1. So that tells me from the original function going down 1, I know that it's going to be, my horizontal asymptote is going to be -1. Okay? And then this right here, that's going to go right 1. This original graph, that's going to push it right 1. That's going to push it down 1. So if you ever got the question that said, you know, what's the horizontal asymptote of this? It's going to be whatever's on the outside. If there's nothing there, then the horizontal asymptote is y equals 0. If there is something there, it's going to be y equals -1. Now this graph, okay, is going to do something like this, guys. It's going to do something like this right here. Okay, now notice here that this was going up, this is going down. Okay, going up, going down. All right, notice back here, we had these going up and these going down. Can someone type in the chat box, what is the difference in the functions? What is the difference right here with this whole B thing? What is the difference when it's going up and when it's going down? Very good, Abby. So it has to do with them being whether B is greater than 1 or if it's less than 1. Okay? If it's greater than 1 or if it's less than 1. Okay? So a graph when B is greater than 1, okay, is going to look like this right here, guys. It's going to look like that. Okay? And we call that exponential. Make sure you're writing these notes down. We call that exponential growth. Exponential growth. It's growing exponentially. And when B is less than 1 but greater than 0, so that, aka that means it's a fraction, Not, I mean, of course, 5/4 isn't between 0 and 1, but it's some kind of fraction where the numerator is less than the denominator. Then you're going to have this right here a graph going down. And that's what we call exponential decay. You're going to see this more in science, okay? See growth more in numbers, and I mean, you could see it in science as well. Most real things don't kind of grow exponentially, like a human, or we grow at a very linear rate, or pretty much linear. I guess you could say, but over time, from 0 to 18, your graph would be pretty steady that you're increasing. But you could have a little bit of a spike at certain ages. So, but most you see a lot of decay in science when it comes to just different type bacteria. And again, if you're thinking about all of this, this right here, if you're thinking about coronavirus, when you hear them saying flattening the curve, that's what they're talking about, is this right here. Okay? They're talking about that curve right there. At first, it grew exponentially, but what they wanted to do was push this curve down so that number doesn't get as high. So it grew exponentially, and then it's going to actually, prayerfully, it exponentially decays, and then it is gone. So when you hear them say, we're trying to flatten the curve, that's the curve they're talking about, and it comes all back to simply just some math. Okay, so there is a that's basically it, guys. If you can know when let's go back here and look. When b is greater than 1, it's going to be an exponential growth. When b is less than 1, it's going to be an exponential decay. Okay? Okay. All right. Give me thumbs up if you're good today. Feeling pretty good about this. Hey, I do, on your homework, for number 5 and number 7 and number 8. Number 7, let me get a different pen. Number 7 and 8. Use your calculator. I'm fine for you. Use your calculator. And you can get the table and do that. I still want you to find everything about it. Find the domain. So still find the domain range and all that, but just use your calculator to get the table. All right, do we have a quick 3 minutes for a story? Abby's comment reminded me of a story. Do we want a story right now? Or are we good to go? What do y'all think? Story, or let's go ahead and call it a day? Okay, so I'll make the screen a little bit bigger. I don't know how funny this will be. I really have no clue how funny this will be with it being like this. Okay, but one time we had a parent-teacher conference. Okay, and at our old school, or at a school I previously taught at. And this could be anywhere because I've taught in 2 schools, but 3. This would be the 3rd school I taught in. So in one of those other schools, we did have a teacher that was fairly short. Okay, that was pretty short. And when Abby said midgets and their growth spurt, it kind of reminded me of this, okay? And when I say short, I'm probably classified potentially maybe as, a midget. I don't know what classifies, but potentially classifying as that. And look, you're already laughing. So this is not my wife either. My wife is not a midget. She's 5 foot tall. Okay, so let's go ahead and take that out of the equation. So during parent-teacher conference one time, there was a family that came in. Now this story is told to me. Okay, there you go, Maddie. Thanks, Maddie, for your phenomenal knowledge of short people. So, call me midget one more time. No, I'm just kidding. Or no, what do you say, dwarf or elf? Elf. Call me elf one more time. So, okay, apparently all you guys are midget experts. Okay, good job, Abby. So, I heard this story secondhand the night it happened. All right, so, and I died laughing when it happened. So, I don't know how funny it will be here because you don't know the people. If you knew the people, it may help you a little bit. But a family comes into parent-teacher conferences. Now, in some parent-teacher conferences, some of them are a little bit crazy. And when parents bring in like their other kids, like other small kids, these kids would just run around your room and kind of act crazy, So one day at this parent-teacher conference, this family comes into this very short teacher's room, and they're running around the room. Well, one of the kids with the parent and the other small kids is extremely tall. She's like, I think she was like in 8th or 9th grade, and she was every bit of 6 foot, 6'1". So Division I talent type tall. Okay, so she was there, and her siblings were running around the room. All right, and she walked in, and it was natural for her to call them midgets because she's so tall, they're so short. Okay, so she walks into this teacher's room, not knowing who this teacher is, and her mom's over there talking with the teacher, and she walks in, and these kids are just running around, and she walks in and she says, "Hey, you midget!" And her brother, who is younger than her, he's probably in 5th grade, I think. He points at the teacher and says, "She's right there." So, and then of course this teacher, she was really cool about it. But it was just this crazy night because the boy just pointed because he thought that the older sister was talking about the teacher, and he just said, "She's right there." So crazy story. That's my best short person story I've ever heard, and we still don't let that one die down. So my wife's giving me very funky looks right now. So I may be in a little bit trouble. So, but my wife will say something to you guys.
Hey guys, how are you doing?
They can't talk to you.
I know that, I was looking.
They want me to do Zoom so they can talk, but I refuse. Hunter Gossett, what's up, man? But nevertheless, see, now we're getting a whole type of people on here. Abby, don't talk about my wife. I still have to grade your final. So, all right. But just they all ask you, "Good, how are you doing?" She said she's doing extremely well. All right. Hey, real quick, guys. That's all we have for today and that. Just to kind of show you that schedule. If we're looking at that schedule, guys, for the for your class for the next 3 weeks. That looks like this. So just looking at it with you real quick. Let me get out of the way. So here's your schedule for the next couple weeks. Couple things. Let's make sure you turn your assignments in from Chapter 5. Make sure you get it to me by 4 o'clock on Friday. dropping it off at the school or sending me the PDF. All right. I'll see you guys back here at YouTube Live at 2:30 p.m. We'll review 6.1 homework. We'll complete 6.2 notes. If you don't have any questions of me, you guys feel free to log off. Thank you so much for being here. Thank you so much. Can we give a round of applause to Elizabeth and Elena for joining us today? Thank you guys so much for joining us. We appreciate you guys, especially you special guests being here today. Do you have any other questions? Make sure you knock out that homework. Email me with any questions. If not, I'll see you guys on Monday at 2:30. If you have questions, please go back and check it out. Or email me, whatever. Redo the lecture. If you have any questions, I'm here for a few minutes. Let me know if you have any questions. Yes, you guys have a good day. Good day, Christina. Good day, Bernice. Good day. See you, Hunter. Hey, man, I hope you're doing good, Hunter. I hated that you guys, your baseball season, man. Hate to hear that. I was looking forward to following you guys on Twitter. Hit me up sometime, Hunter. See you, Lucy. See you, Elizabeth.